Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 21, Unit Circle Trigonometry. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so as you might be able to guess, you can actually do a lot of the Unit Circle Trigonometry on the SAT on a quality scientific calculator. I actually have two videos on this already. One is for the Casio FX991EX, which has unfortunately been discontinued. One is for the TI-30X Pro Math Print, which is a little bit hard to get your hands on. Again, if you're curious about that, go check those videos out. I made this little graphic here to kind of sum up what I was talking about in the quadratic formula video. So again, really like the TI-30X Pro Math Print, but it's kind of hard to get if you don't live in like Europe because they don't really make a lot of them. So these other two options are really good. If you like Texas Instruments, go with the TI-36X Pro. Just keep in mind it can't do quadratic formula. And if you really like Casio, go with the FX115ES Plus Second Edition. That can do pretty much everything you'd want it to do on the SAT. And really, if you go and watch my pink videos that I just showed, the inputs for both of those different models will still be very similar, so you should be able to follow along. I'll try to go over some of it here too. And just some prior viewing that you're really going to need to watch, otherwise this is a very hard topic, so if you haven't watched these videos, this probably isn't going to make any sense. So you should definitely check out my Ottocento videos on special right triangles and SOHCAHTOA. And I also have two shorts that are really relevant here, one on Pythagorean theorem and one on converting between degrees and radians. We're going to be doing all four of these things just on the fly without even thinking, so make sure you understand all the concepts covered in these videos. All right, so this is the unit circle. So the unit circle is a circle centered at the origin with a radius of 1. That's where the name unit circle comes in. Unit means 1. When we try to measure and draw an angle using a circle centered at the origin, we read it using what's called standard position. So standard position, to do that, you start along the positive x-axis and then rotate counterclockwise. So you see at the positive x-axis, it starts at 0. And then if you rotate counterclockwise, we hit 30 degrees, 45 degrees, 60 degrees, etc. You can memorize this, and it can save you a lot of time, but it's probably not really worth it. And if you have a physical calculator that can do this stuff, it's definitely not worth it because it can do all the special trig values for you, as you'll see. So let's say I wanted to plot 225 degrees. I would start along the positive x-axis, and then I would rotate counterclockwise, so the opposite direction a clock goes, so like this. And then I'm kind of seeing that 225 degrees is between 180 and 270, so I'm going to stop in the third quadrant. So it will look something like this, and you will see that 225 degrees is kind of this angle, kind of like on the outside, almost like a major arc, which looks like this. So this could be a little disorienting, like, wait, what's this idea, Kyle, that there can be an angle bigger than 180 degrees? Well, unfortunately, that's just kind of something we got to get used to. And I'll show you on the next slide something that'll hopefully clear that up some. But first, some vocabulary. So this guy here, we call this the terminal side of the angle. That's not super important, but what's important for the SAT is that you understand this concept of a terminal point. So the terminal point is the point on the circle where the angle kind of ends. In other words, not the positive x-axis. So you see here, it's point B. We call that a terminal point. So what I did here to kind of help you get familiar with what the drawings will look like is I generated a figure for an angle from each of the four quadrants, and you kind of see it has nothing to do with how big the angle is. You're always going to do that side from the positive x-axis, rotating counterclockwise. How's this, Squidward? What? a perfect 300-degree theta. Do it again. Show your process. Well, first I draw this fully labeled unit circle. Then I erase some of the finer details. And 1, 2, 3, a theta thingy. Grr, forget the theta. Okay, so in order to do a lot of these problems, we're going to need to be really familiar with the special right triangles. This is exactly what it looks like on the reference sheet. However, I'm going to show you two other ways to write them. One in which I find really helpful for solving these. You could just use these, and if you did the trig ratios, like you would get, like, for example, 2x over x, and the x's would cancel. So it doesn't matter, but let's talk about that more. So one way to do it that you're commonly taught is to make the radius 1. So the radius is like the hypotenuse of the triangle. So just trust me on this, if I made the radius 1, if I made the hypotenuse 1, this is how the math would shake out. And you could kind of imagine doing trig ratios with all these fractions is not going to be fun, and we're probably going to make a mistake. So even though it might make more literal sense to make the hypotenuse 1, I highly suggest you do not do this. What I suggest you do is just take the special right triangles and then replace x with 1 and s with 1 so that it looks like this. And this is what we're going to be using for the rest of the video. I'm just going to pull this out and we'll figure out the trig ratio super quickly. So make sure you understand this. Keep in mind, you don't really need to memorize it because you can look at the thing from 2 slides ago on the reference sheet, and then you can just make x1 and s1, and it all comes out like this. It's hopefully pretty intuitive. All right, and in school, you're kind of taught to learn the special right triangles in radians as well, in case you get a measurement in radians. But that doesn't really matter for the SAT. All you care about is the answer. They're not checking your work. So here's what I suggest you do if you get an angle in radians. Just change it to degrees. That's what I'm going to do the entire video. So as I talked about in my circles video and my degrees and radians video, to go from radians to degrees, we multiply by 180 over pi. So just degrees you are way more familiar with than radians. So just taking 10 seconds to type that in your calculator and figure out what it is will save you a ton of confusion. Next, we got all students take calculus, which, by the way, is propaganda. So if you didn't know, not all students do take calculus. Yeah, so even in America, lots of people take like pre-calculus or algebra 2, and at certain schools, that's enough for them to graduate, and then they never take math again. So it's not really true, but it's a helpful way to remember what I'm about to show you. So if we kind of start from the first quadrant and move counterclockwise like we were talking about before, ASTC. So in the first quadrant, all 3 trig ratios are positive. So sine, cosine, and tangent are positive. In the S quadrant, sine is positive, but the rest are negative. Cosine and tangent are negative. In the T quadrant, tangent starts with T. Tangent is positive, and sine and cosine are negative. And then cosine starts with C. So in the fourth quadrant, cosine is positive, and sine and tangent are negative. I would definitely make sure you know this. A lot of sources of errors for people is that they do everything right, and then at the very end, they forget to check to make sure if their answer needs to be negative or not. So just make sure you know this. All right, so what is a reference triangle? Well, I'm going to show you in a problem, but first let me give you a definition. So we've got the angle in standard position, and it's formed by the terminal side, as we were just talking about, and the x-axis. And it says a perpendicular is dropped from a point on the terminal side to the x-axis. So that's a big takeaway. You need to drop down, up or down from the terminal point to the x-axis. You don't go left or right towards the y-axis. That's a common mistake. I'll show you in a minute. Do not do that. The other common mistake is that people are like, which one's the reference angle? Is it the one far away from the origin or the one close to the origin? It's the one close to the origin. So see how it says the angle in a reference triangle at the origin is the reference angle. So let me show you a little example. We're not going to do the whole thing. No, actually we are. The first one we are. And you guys can kind of see what I mean. All right. So let's say we want to find cosine of 120 degrees. No calculator, no memorization, no anything. So 120 degrees is between 90 and 180. So that's going to be in the second quadrant. And what I'm going to do now is I'm going to drop a perpendicular, in this case, down towards the x-axis. And hopefully you kind of see if that's 120 degrees, this that like straight line or semicircle is 180. So that means that angle there is 60. So I'm going to drop the perpendicular. Very common mistake is that people will go from the terminal point left or right towards the y-axis. That is wrong. Do not ever do that. Okay, see how I went down towards the x-axis? That's the definition of a reference angle. Okay, so the reference angle is close to the origin, so it's 60 degrees. 90 minus 60 is 30, so that angle up top, which is not the reference angle, is 30 degrees. And now we kind of see, oh, this is a special right triangle. So we're going to pull up the special right triangle. And we're going to label the sides accordingly. So across from 30 is a 1. Across from 60 is a √3. And the hypotenuse is 2. Now we're going to do cosine using SOHCAHTOA. So cosine is adjacent over hypotenuse. And again, guys, we're looking at that reference angle, the one closest to the origin. So that's this one. The adjacent is 1. The hypotenuse is 2. So the cosine of theta, in this case 120, is 1/2. But I have to do, all students take calculus and check to see if it's going to be positive 1/2 or negative 1/2. So don't forget to do that. So I'm going to pull up that little chart. And it seems like we are in the S quadrant, but we're measuring cosine. So cosine should be negative in that quadrant. So the answer is negative 1/2. And you can kind of see here, all right, well, I did that on my calculator, my physical calculator, in like 5 seconds. And because this one comes out nicely, you can actually do it on Desmos too. You just have to make sure you put it in degrees first by clicking on the little wrench. And that's pretty convenient. However, I'm going to go ahead and encourage you not to use Desmos for these, because Desmos, as you'll see with the later ones, cannot give radical trig values. So if the answer were √2/2, it's not going to be able to tell you that. But the physical calculator can. On top of that, regardless of whether you have a physical calculator or not, some problems are kind of designed by College Board so that you're kind of forced to do them by hand. So, I don't know, I would just encourage you not to get too reliant on using Desmos for a lot of these problems, pretty much all of them. Okay, so should you rationalize the denominator? Well, I'm going to say almost always. So essentially the problem is, if you simplify, a lot of these questions, not in my slides or my worksheet, but a lot of the questions on the actual exam are multiple choice, because if you get like √3/2, there's kind of not really a way to type that in. They could come up with a way to, like, a roundabout way to ask you about it. So you should still be prepared. But a lot of these questions are going to be multiple choice. So you're going to see, for whatever reason, sometimes, maybe I guess to make it easier to see, they don't simplify in the answer choices. So just make sure you're kind of wary that there might be like 2 ways to write the answer. When in doubt, you could always just type it in your calculator, Desmos or whatever, and look at the decimal output and guess and check once you have the answer. Very annoying. I don't know why they do that. They should just make it so you simplify always, right? It doesn't make any sense. Anyway, so if you don't know what rationalizing the denominator is, there's a great video I just put on the screen by Brian McLogan. He goes over, it's called Rationalizing the Denominator with a Radical. He goes over how to rationalize 4 divided by square root 3. There are more complex ones than that, but pretty much if you understand that one, you're good. So I would go watch that. All right, so now I went through it kind of fast in the 120 degrees example. So I'm going to take a deeper dive into helping you guys figure out how to find the reference angle. So in the first quadrant, theta, the total amount we rotate, and the reference angle are the same. Hopefully that kind of makes sense, because the angle it makes with the x-axis and the total amount we rotate are the same. But in every other quadrant, it's different, so that can be confusing. So in the second quadrant, the theta, you rotate to the blue line, and then the theta reference is the blue dot. They are supplementary. So theta plus the reference angle is equal to 180 degrees. For the purple, you rotate to the negative x-axis 180 degrees, and then you go the rest of the way, the reference angle, to get to the purple. So 180 degrees plus the reference angle equals theta. And then for the green, we rotate theta, and then there's a reference angle left, and it totals a full revolution, in other words, 360. So theta plus the reference angle is equal to 360 degrees. Now, almost always, they're going to give you a big angle, theta, and you're going to have to find the reference angle. So I'm going to rearrange these equations on the next slide to make your life a little bit easier. So in the first quadrant, theta reference just equal to theta. In the second quadrant, you do 180 minus theta. In the third quadrant, you do theta minus 180. And in the fourth quadrant, you do 360 minus theta. I would definitely make sure you know this. We're going to do this you should be able to hear an angle between 0 and 360 and tell me the reference angle within 10 seconds. So let's do an example where we just set up the reference triangle. We're not going to solve it. So for this one, let's say I want to do tan of 210, so theta is 210. I'm looking here and I see 210. That's probably in the third quadrant. So that's where we're going to draw our terminal side. And the reference angle, as we talked about in the third quadrant, is theta minus 180. So if I do 210 minus 180, I get 30. Oh, that's pretty convenient. All right, so I'm going to draw the terminal side. And then the reference angle, the angle in that triangle closest to the origin, is 30 degrees. And then I could go and find the other angle, and then I could start labeling the sides and solve the question. So make sure you're able to do that in about like 10 to 25 seconds. All right, so what is the value of sine of 7 pi over 4? So notice, guys, how there's no degree symbol inside the trig function, like next to the 7 pi over 4. That means it's in radians. So remember what we talked about? We want to, if it's in radians, we want to put it in degrees. It's just going to make it so much easier. So I'm going to multiply by 180 over pi on my calculator, and I get 315 degrees. So the question is essentially asking us, what is the sine of 315 degrees? Let's just use that because it's going to be way easier to wrap our head around. All right, so 315 degrees, I believe that's between 270 and 360. So that is in the fourth quadrant. And so let's draw that. Oh yeah, and also the reference angle, we got to do 360 minus theta. So we're going to do 360 minus 315, that's 45 degrees. So the reference angle is 45 degrees. So let's draw it. And then the reference angle, the angle in that triangle closest to the origin. Notice how, guys, when I drew the reference triangle, I moved up towards the x-axis, not left or right. That's important. Moved up towards the x-axis, up or down. We're going to put the reference angle 45 degrees there. 90 minus 45 is 45. So this guy's also 45, but he's not the reference angle. That's just helpful. And now it looks like a nice isosceles right triangle. So we're going to pull that up. And we'll label the sides. For this one, the hypotenuse is root 2. This one's much easier to see, so I won't go through it slowly. And now we're going to do sine. So sine is opposite over hypotenuse. So looking at the reference angle, the opposite is this one over here. And the hypotenuse is root 2. So we're going to do 1 over root 2. And then we're going to rationalize the denominator because there's a square root on the bottom. So we'll multiply the top and bottom by that square root. In other words, square root of 2. and we get square root of 2 over 2. But once again, I have to check ASTC to see if the answer is positive or negative. So let's do that now. So I'll pull that up. Looks like we are in quadrant 4, and we want sine, but we're in the cosine quadrant. So that means it's negative. So the answer is negative root 2 over 2, or which is simplified, or if it was unsimplified in the multiple choices, it would be maybe like negative 1 over root 2. Kind of depends on whatever the SAT chooses to go with. So just be aware that both of those are kind of answers, though we really should simplify it. And of course, as you can see, sine of 7 power 4, if I put my physical calculator in radians, it tells me that answer in 5 seconds, which is incredibly, incredibly helpful. A really big time save if this question comes up. All right, so one thing the SAT does to make these questions a little bit harder is they give you what's called a coterminal angle. So coterminal angles are two angles having the same initial side and the same terminal side. In other words, they're in the same position. All their trig values are the same, and their values, their angle measures differ by multiples of 360 degrees. So picture like the circle as like you're turning like a crank counterclockwise, and you're like at 45 degrees, but you like turn the crank like 6 times, 6 full rotations, you end up in the same spot. So that's kind of the idea. So let me show you what to do when you see these. So what you're going to do is if you get an angle that is outside of the range from 0 to 360 degrees, what you're going to do is you're going to add or subtract 360 repeatedly until the angle is in that range, and then we'll just solve the problem and do everything what we did before. It's just one annoying extra step. So let's look at this one, sine of x negative 675. That is smaller than 0 to 360. So what I'm going to do is I'm going to add 360 over and over again. So still not between 0 and 360. You got to do it again. And you don't need to do this on separate lines. I just did this for the sake of the slides. You can just keep typing plus 360. And I got 45. Okay, so a coterminal angle that we're more familiar with is 45 degrees. So we would solve the rest of that question as sine of 45 degrees. Makes it much easier. Okay, let's look at tan 1410 degrees. So that's bigger than 0 to 360. So I'm going to subtract 360 repeatedly until I get a number I want. Still too big. Still too big. 330, that's between 0 and 360, so we would solve the rest of this question as tangent of 330 degrees. Let's actually do an example where we have to do this. All right, it says, what is the value of tangent of 43 pi over 6? So first things first, we're going to change that to degrees every time right away. So that's 1290 degrees, so it's basically asking us, what is the tangent of 1290 degrees? So now it's too big, so I gotta start taking away 360. And I see that a coterminal angle that I would want between 0 and 360 is 210 degrees. So let's solve this problem as if it's just asking us tan of 210 degrees. That'll make the rest way easier. All right, so first things first, I'm thinking this is in quadrant 3. Then I'm also thinking the reference angle is 210 minus 180, which is 30 degrees. So let's draw that. So we got our reference triangle. We went up towards the x-axis. And then the 30 degrees goes closer to the origin. And then 90 minus 30 is 60. So this guy over here is 60. We got a 30, 60, 90 triangle. Across from 30, we put the 1. Across from 60, we put the root 3. And across from the right angle, we put the 2. Now we're going to do tangent. So opposite over adjacent. Looking at the reference angle, the opposite is 1. And the adjacent is square root of 3. So we're going to do 1 over root 3. But I got to rationalize the denominator, so I'm going to multiply the top and bottom by square root of 3. and I get root 3 over 3. But once again, I have to check the ASTC to see if it's positive or negative. So I look at my little chart here. You can scribble this down on your scratch paper, this shortened version. That's what I always do. And in that quadrant, that is the tangent quadrant. So tangent is positive in that quadrant. So we're good. So the answer is just positive root 3 over 3. And unsimplified, that would be 1 over root 3. So probably one of those would show up in the answer choices. And once again, guys, if we put that in our calculator in radian mode, we did not need to do any of it. Get the same answer, square root 3 over 3. Okay, so not always will the question end up giving you a reference triangle that forms a special right triangle. Sometimes it's just some other triangle. And you often need to use the Pythagorean theorem to find like a side length or something. So in this one, they tell us that, and they might not always be this on the nose about it, but just for this example, they tell us we're between 90 and 180. So that means we're in the second quadrant. So let's draw that. Okay, now what we're going to do is we're going to label the sides. Technically, we would put like 55A or 5573A, but let's just pretend it's like 55 and 73 because the trig ratios are going to be the same, right? So opposite over hypotenuse. So the opposite should be 55 and the hypotenuse should be 73. Now, for tangent, I'm noticing I need the adjacent side, which we don't have. So I'm going to use Pythagorean theorem to find that adjacent side. So we're going to do a squared plus 55 squared equals 73 squared. I evaluate the squares. I move the 3025 to the other side using subtraction. Then I take the square root of both sides. And I see that A is equal to 48. So let's go ahead and get that up on the picture. Now we're going to do tangent of theta. So that's opposite over adjacent. So that's 55 is the opposite, 48 is the adjacent. So we get 55 over 48, and that doesn't simplify, but I gotta check ASTC just like always. So let's look at that. I am in the S quadrant, and we want to find tangents. Those don't line up, so that means it must be negative. So tangent is negative in that quadrant, and that gives us a final answer of negative 55 over 48. Now, none of this is very helpful. There's no way typing all this in and figuring this out is going to be faster than what we just did. Remember, guys, I'm going slower for the demonstration, right? But you could figure out the reference angle using inverse sine, which is in this in the functions menu. It's like the second thing down. You can't miss it. And then we could find the actual theta by doing some quick arithmetic. And then you could find a tangent of that angle. And it would, as long as I'm in degrees, it would give me the answer. And it even simplifies if you click the fraction button. So that's really crazy, but I don't think it's any faster than doing it by hand for this one at least. So I would just do this to, in case you're curious, to verify while you're practicing. Okay, so as I was saying before, they might not be super on the nose by just telling you what quadrant you're in, by telling you the theta. So sometimes, just like when you figure out where the vertex of a parabola is, you have to think about it using the sign of the coordinates. So if both coordinates are positive, you're in the first quadrant. If the x-coordinate is negative, but the y-coordinate is positive, you're in the second quadrant. If both coordinates are negative, you're in the third quadrant. And if the x-coordinate is positive, but the y-coordinate is negative, you're in the fourth quadrant. So just make sure you think about that if you get a harder problem where they don't just tell you. There might be one like that in the worksheet. All right, so here's some stuff about terminal points and their coordinates. This could come up once in a blue moon. So we'll talk about this, but here's how I like to do it. I like to do it using these equations you learn in pre-calculus. So x equals the radius times cosine theta, and y equals the radius times sine of theta. Kind of easy to remember, they're in alphabetical order: CS, cosine sine, XY, cosine sine. Now, as you'll see a lot of times on the exam, they give you a circle with radius of 1. So these equations simplify to x equals cosine theta and y equals sine theta. And this I would definitely jot down and make sure you know, because there actually is a, decent chance that could come up. They have asked it once in a blue moon for students to make this connection. Again, remember CS, if that helps you remember CS. It's in alphabetical order. All right, so let's take a look at this question. We'll break it down on the next slide. I'm kind of already noticing the terminal point, 5/13, 12/13, they're both positive. So I'm going to be in the first quadrant. And indeed, that is the case. Let's label everything. So get 5/13, 12/13, 0, 0, and 1, 0, because they said it was at that point. So the horizontal distance from the origin to 1 is just 1. Hopefully that makes kind of intuitive sense. So this is the unit circle. And they want us to find cosine of AOB. That's just the theta, right? So they want us to find cosine of theta. Well, we know x equals cosine of theta. So the x coordinate is 5 of the terminal point is 5/13. So I can just put that in the equation, and 5/13 is equal to cosine theta. And sure enough, that's the answer. So you see, if I understood that, you could go and make the triangle and label 5, 13, 12. But I didn't even need to do that. I just know when the radius is 1, the x-coordinate is cosine. And if it asked me sine, I don't even need to think about that. I would just say 12/13. So here's a little bit of a harder one. And take a second to read this. Maybe pause the video. And you will see that they tell us L is negative and M is positive. So let's just pretend the 120 degrees isn't even there. Although it might not be, it might be. L is negative and M is positive. So that means I'm in the X is negative, Y is positive. That means I'm in the second quadrant. So just be prepared to figure that out, as I was talking about a couple slides ago. So we're in this one. And again, for this one, they told us the 120, but they might not be so on the nose about it. Maybe you'll see a harder question on the test or in my worksheet, so just be mindful of this. All right, let's make the picture. And if you'll humor me, 120 degrees we already did earlier in the video, so I just copied it. And let's put the coordinates on there. OA, the initial side, has a length of 4. So that means the radius is 4. So we're going to do y equals r sine theta to find the y-coordinate m. So m is equal to 4 sine theta. So what is sine theta? Well, opposite over hypotenuse, it's root 3 over 2. And it is indeed positive because we're in the S quadrant. Sine is positive in that quadrant. And you could also look, y is positive in that quadrant. So 4 divided by 2 is 2. So the answer would be 2 root 3. So now you might be wondering, well, Kyle, why is that guy 2 if the radius, they're both radii? That guy's 2, and you just said the radius was 4. Well, those sides on the length, remember, if you do it this way, we only care about the actual trig ratio. So those sides on the left don't represent actual sides. We're just using that to find the trig ratio. If we did make it 4, we would still get the same answer. So that's what I'm going to do on the next slide, just to prove it to you. Again, I just think this is harder for me personally. So to get a similar triangle with a hypotenuse of 4, I'm going to multiply everything in that triangle by 2. So let's do that now. Okay, we get 2 root 3, 2, and 4. And now you see, wait a minute, now that it's a literal representation, I don't even need to do it using the formulas. I can just look at the legs. So 2 left, so that's negative 2, and then up 2 root 3. That's positive 2 root 3. So I just figured out the coordinates like that. All right, that's pretty good. However, kind of the problem with doing this, first of all, you need to be mindful of the signs, as I was there. Left is negative x. And the other problem is these numbers aren't always going to work out so nicely. So you could imagine, especially for like a 45, 45, 90, it might be more complicated to get the radius that you want. So I would still just do it using the first way and just kind of forget about those sides not being literal representations. Again, the arithmetic can get messy. And once again, it really just doesn't matter, because if you know the formulas, you could just do this on a physical calculator in 2 seconds. So again, I'm really just trying to make this video, first of all, to be thorough. 2, lots of people have been requesting it. But 3, like, I just know lots of people, especially like overseas, they either don't have the money for a calculator, or they can't get it shipped to their country. There's a lot of shipping and like hurdles and things like that. So I'm just showing you guys, if you do have a calculator like this, it could save you a lot of time, even on this really hard question we just did. And in case you are curious, one final thing. I don't think I've seen a question like this. They usually give you at least one of the coordinates, but if you get a question where they give you both of the coordinates, there's a really quick way to use the calculator, even Desmos, to, if it's a special angle, to find the theta using the coordinates. So there's another equation that the terminal point also follow. Tan of theta is equal to y divided by x. So this means that the reference angle is equal to the absolute value of tan inverse y divided by x. So it's kind of a lot to remember, but if you know that equation, you could take the coordinates of a terminal point and get the reference angle in about 10 or 20 seconds, and then solve the rest of the question. So let's say here it's 5 comma negative 5. And you can see it's in quadrant 4 just by thinking about the signs like we were talking about earlier. And if I do the absolute value of tan inverse negative 5 over 5 y over x, I get a reference angle of 45 degrees. That's very helpful. And that would mean that theta is, they have to add up to 360, so probably 360 minus that, which is 315. So that green arc, that green theta, the thing we care about most of the time, is 315 degrees. So could you have figured that out using specialized triangles and everything? Absolutely. And I'll be honest, I don't even know if this would be a test question. I'm just trying to be thorough, and I also just think this is kind of neat. But yeah, it's like, man, if you know this forwards and backwards, there are ways to quickly solve these the vast majority of the time. All right, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's jump to the whiteboard for the final review. Okay, question 1. So for things first, 30 degrees is between 0 and 90. So we're going to draw our line here in the first quadrant. Doesn't have to be perfect, just has to be in the right quadrant. And I'm going to drop a perpendicular towards the x-axis to make my reference triangle. This guy in here is 30 degrees because the reference angle is equal to theta in the first quadrant. That means this one over here is 60 degrees. 90 minus 30 is 60. Then we look at the special right triangles that I had on the slides. Across from 30 is 1. Across from 60 is root 3. And the hypotenuse is 2. And we're going to do sine, which is opposite over hypotenuse. So we're looking here, and we're going to do opposite over hypotenuse. So that is 1/2. And if we do ASTC, we are in the all quadrant. So all three trig ratios are positive. So our final answer is going to be positive 1/2. Let's put it in the calculator and make sure we did it right. All right, looks good. Okay, question 2. So for this one, 135 degrees is between 90 and 180. So I'm going to draw my terminal side in the second quadrant. And the reference angle in that quadrant is 180 minus theta. So we're going to do 180 minus 135. And that should give us 45 degrees. And so when I drop my perpendicular to make my reference triangle, this guy in here should be 45 degrees. And the remote angle is 90 minus 45. That's also 45 degrees. We label the sides as 1, 1, and root 2, as we did earlier in the video. And now we just have to find the tangent. So tangent of 135 degrees. Again, looking at this reference angle near the origin, is opposite over adjacent. So we're going to do opposite over adjacent. So that is 1 over 1, which is just 1. But now we have to check all students take calculus. And I see that tangent is we're in the S quadrant right now. So in this quadrant, tangent is negative. So the answer should actually be -1. And that's going to be our final answer. Let's check it on the calculator. Okay, looks good. Okay, question 3. So first things first, I see that it is in radians. And we don't want that because we're not as comfortable with radians, most people. So I'm going to fix that by multiplying by 180 over pi. And if you do that on a calculator, you should get 300 degrees. So the question's basically asking us for cosine of 300 degrees. I am noticing that that is between 270 and 360, so I'm going to draw my terminal side in the fourth quadrant. And in this quadrant, we find the reference angle by doing 360 minus theta. So in this case, 360 minus 300, and that is 60. So let me drop my perpendicular towards the x-axis. Notice I'm going up or down. And the reference angle, the one closer to the origin, is 60. 90 minus 60 is 30, so that goes here. And across from 30, we're going to put a 1. Across from 60, we're going to put a root 3. And the hypotenuse is 2. All right, and now we're going to do cosine. So we're going to look at this reference angle and do cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So that should be 1/2. But I got to check ASTC. And we want cosine. And we're in the cosine quadrant. So we should be good. Cosine should be positive there. So the answer is indeed positive 1/2. Let's check it on the calculator. Okay, looks good. Okay, question 4. So negative 840 degrees is outside of the interval from 0 to 360. So we're going to have to find a coterminal angle in the correct range. So let's go to Desmos and figure that out. So let's say I have negative 840. Because it's too small, I'm going to add 360. So let's add 360. Still too small. Add 360. Still too small. Add 360 again, and I get 240. That's between 0 and 360. So let's jot that down. So the question, another way to write the question is basically just tan of 240 degrees. That'll help us a lot. Okay, let's come back over here. All right, so 240 degrees, that is between 180 and 270, so quadrant 3. And I'll draw my reference triangle. In this quadrant, to find the reference angle, what we do is we do theta minus 180. So here we're going to do 240 minus 180, and that is 60 degrees. So the reference angle should be 60. 90 minus 60 is 30, so this guy is 30. Now, across from the 30, we're going to put a 1. Across from the 60, we'll put a root 3, and the hypotenuse is 2. Now we're going to do tangent of that. So looking at this angle, this reference angle, tangent is opposite over adjacent, so root 3 over 1. So tan of 240 is equal to root 3 over 1, or in other words, just root 3. But I gotta check my ASTC. All students take calculus. All right, so we want to find tangent, and we're in the tangent quadrant. So I'm betting this guy should be positive because tangent is positive in that quadrant. So I believe our final answer is just positive square root of 3. Let's go check it on the calculator. Okay, looks good. Okay, question 5. First things first, we do not like radians. So let's change that to degrees. So times 180 over pi. And I did that on a calculator. I should get 1,950 degrees. And now that is a really big angle, bigger from 0 to 360. So we got to find a coterminal angle on the interval from 0 to 360. So let's come over here. And we're going to do 1950. But because it's too big, we'll take away 360 a bunch of times. And I'll just keep doing it. Still too big. Just do it a bunch of times. 150 degrees. So this question's basically asking us cosine of 150 degrees. That'll make the question way, way easier. Okay, let's come back over here. All right, so 150 degrees, that's in quadrant 2. Somewhere like that. In this quadrant, to find the reference angle, we do 180 minus theta. So in this case, 180 minus 150. That's equal to 30 degrees. So the reference angle is 30 degrees. Let me make sure I draw my reference triangle. All right. And 90 minus 30 is 60. So this guy over here is 60. Across from 30, we're going to put a 1. Across from 60, we're going to put a root 3. And the hypotenuse is a 2. And we want to find cosine. So let's look at the reference angle. That's adjacent over hypotenuse. So the cosine of 150 should be root 3 over 2. And now I just have to check ASTC. And certainly it seems like we are in the second quadrant and we want to find cosine. Cosine doesn't start with an S, so cosine must be negative there. So the answer is really negative square root 3 over 2. Let's check it on the calculator. Okay, looks good. Okay, question 6. So this part here basically just tells us we are in the third quadrant. So let's draw that. I don't know exactly where it's going to be, but I'll just draw it somewhere in there. I'm going to make my reference triangle. And I don't know what the reference angle is. I don't think I really have a good way to find it, so I'll just call it theta reference. But they do tell us that tan of theta is 13 over 84, so that's opposite over adjacent. And even though I don't know it's exactly 13 and 84, I can just suppose they're 13 and 84 for the sake of finding other trig ratios, because when I do a fraction, no matter what I make it, if I make it 26 and 170, whatever, you know, it would still simplify the same. So it doesn't matter, might as well just keep it simple. So let's make the opposite 13 and the adjacent 84. And now we want to find this side here so that we could figure out more about this shape. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. 13 squared plus 84 squared equals c squared. I just do 13 squared plus 84 squared on my calculator. That is 7225. And now I take the square root of both sides. The square root of 7225 is 85. So 85 is equal to c. So I will put an 85 here. And now we're going to do sine. So opposite over hypotenuse. So let me look at the reference angle, and then we're going to do opposite over hypotenuse. So that is 13 over 85. That does not simplify if you put it in a calculator. And I have to check the sign, SIGN. So we are in the T quadrant. Sine and cosine are negative there. Tangent is positive, but sine and cosine are negative. So I am going to need a negative sign. So the answer is negative 13 over 85. Let's check it on the calculator. So as I was talking about in the slides, there isn't really a good way to check this one on the calculator, but I did some of the the numbers anyway, just for the heck of it. So I found the reference angle by doing tan inverse of the tan ratio they gave us, and I took the absolute value, calculated the actual angle, 188 degrees, 189 degrees. That seems plausible. That's in quadrant 3. And then I did the sine of that angle, and you see it gives the same decimal output as negative 13 over 85. So it seems like we did it right. Let's keep going. Okay, question 7. Little typo that I fixed on the worksheet that you downloaded. Should say cosine theta, fix that. All right, so it says 270 is less than theta less than 360. So that means we're in quadrant 4. And you see that kind of lines up with what they told us. They told us that sine is negative, and sine is negative in that quadrant. So seems like we're probably in the right place. Let's make a reference triangle. And I don't know what the reference angle is, so we'll just call it theta r. And sine is opposite over hypotenuse. So opposite is 35, and the hypotenuse is 37. In order to find cosine, we're going to need that missing side. So let's figure out what that is. So I'm going to do a squared plus b squared equals c squared. So a squared plus 35 squared equals 37 squared. 37 squared is 1369. 35 squared is 1225. If I move the 1225 over, 1369 minus 1225, I'm getting a squared equals 144. And if we take the square root of both sides, that means a is equal to 12. So this missing leg here is 12. And Now we're ready to do cosine of theta. So let's do cosine of theta. So that is so looking at this reference angle, that is adjacent over hypotenuse. So that is 12 over 37. And I believe that's the answer, because if we look at ASTC, so ASTC, we are in the C quadrant. Cosine starts with a C. Cosine is positive in that quadrant. So we don't need to add a negative sign. Let's check to make sure we did it right. Okay, so not really important for the exam, but just a little neat thing that we can do. So I took the absolute value of the sine inverse of the ratio they gave us, and I got a reference angle of 71 degrees about. And then the actual angle is the difference from 360. So that's 288.9 degrees. So that does put us in quadrant 4, so that seems like a reasonable number. We probably did it right. And then if I do cosine of that theta, the actual theta, again, this kind of arc here, then we get 12 over 37. I don't know why, but it came out nicely as a fraction. But even if it didn't, you could just type in 12 over 37, just make sure the decimals line up. But yeah, that's pretty neat. For the one we did before, it didn't come out as a nice decimal, but this one did, so as a nice fraction on Desmos. No idea what that's about, but looks like we did a good job. Let's keep going. Okay, question 8. So this is kind of how they allude to the idea of unit circle trigonometry without telling you verbatim standard position, because I don't think they expect you to know what standard position is. Honestly, it kind of makes it a little harder, but in an effort to make it easier, I think they make it a little harder. It's a little confusing. So anyway, I'll walk you through this. So point A is 1, 0. That's on the circle. The origin, that's 0, 0. So that's O. And then B is negative, positive. So that's in the second quadrant. So somewhere over here. So let's make that B. It's negative 3/5, 4/5. And I'm going to draw an angle AOB. So I'm just going to connect all three of them. And you see, when I'm in quadrant 1 or quadrant 2, theta is the same thing as angle AOB. See, look, AOB, that's this angle. And that's what we care about. That's theta. So the question is basically asking me, what's cosine of theta? Well, as we talked about, guys, let's see this radius here. This is from 0 to 1. So 1 minus 0 is 1. So this distance is 1. So this is the unit circle. So y, so the x is equal to r cosine theta, but on the unit circle, x is equal to cosine theta. So the x coordinate of the terminal point B is cosine theta. So the answer is just negative 3/5. I don't even need to set up a triangle. As long as I know that x is equal to cosine theta, I can get the answer. So I believe the answer is just negative 3/5. And maybe one more thing just for fun, guys. I'm going to perhaps find the cosine inverse of negative 3/5. And I got to change it to degrees. And that is 126.869. And if you look here, this angle measure of like 126.87 degrees seems pretty reasonable. We're in quadrant 2. If it were 0 to 90, I would think it was the reference angle, but because it's not between 0 and 90, I think that's telling me the actual theta, which it is. Great, let's keep going. Okay, question 9. Very similar to the last one, incredibly similar. So this is A, that's 1, 0. This is O, the origin, 0, 0. And it says, really important here, guys, the number j is a negative constant, k is a positive constant. So j, the x-coordinate, is negative, so we go left. And then k, the y-coordinate, is positive, so we go up. So that means we're in the second quadrant, very similar to the last one. And then I'll connect all three of them. They say the measure of angle AOB, so that's this one, is 150 degrees. And once again, guys, we're going to basically, to find x, to find j, we're going to do x equals cosine theta because the radius for this problem is 1. So I don't need to worry about an r. And 1 cosine theta is just cosine theta. So x, or j, is equal to cosine of 150 degrees. And you could go and draw the reference triangle and all that. But we actually already did this in this worksheet already. So it's negative root 3 over 2. And that is the answer. If you're not sure how to do cosine 150 degrees, just go back and see question 5. Because we already did all that. Let's keep going. Okay, question 10. So, what we're going to do is, I basically drew part of it already. It's the same as the last one, the A and the O. And now B, it says J is a positive constant and K is a negative constant. Okay, so X is positive and Y is negative. So that means we're in quadrant 4. So let me draw this. B, which we call J comma K. And you kind of see, guys, that we get a radius of 1, and this reference angle AOB, that's what they told us. AOB, remember that's the smaller one, the minor angle. It's not the other side. So this is 45 degrees. And that means this is 45 degrees. And before we even do it, let's figure out what the theta is, just so that you guys understand essentially what we're doing. So that angle there is 360 minus 45, which is 315 degrees. So the radius is 1, and the question essentially wants us to find k, the y-coordinate. So y is equal to r sine theta, 1 sine theta, or in other words, sine of theta. Basically wants us to just find sine of 315 degrees. That's it. So let's do it. So again, remember, guys, these aren't literal lengths. I'm just going to label the triangle based on the ratio. So if it seems confusing, the numbers I'm picking, that's kind of on purpose. So 1 root 2. I know they're not literally 1 root 2, but like they're in that ratio. Okay, and we want to find sine. So sine, using this reference angle, would be opposite over hypotenuse. So that's 1 over root 2. So it seems like we're getting 1 over root 2. We got to rationalize that because it says expressed as a simplified radical. So I'm going to multiply the top and bottom by root 2, whatever radical's in the denominator. And I get k is equal to root 2 over 2. And now the question told me k is a negative constant, so I can just slap on the negative. But you also should be able to figure that out using ASTC. So you see we're doing sine, and we're in the C quadrant. So sine is negative in that quadrant. So we need the negative sign. So there's kind of two ways you could figure it out, both based on where you are in the circle and the question kind of tells you. Great, let's keep going. Okay, question 11. So it says the numbers j and k A and O are exactly what they were in the last question. And the numbers J and K are both negative constants. So that tells me that B, the terminal point, is in quadrant 3. So we're going to plot that. So something like this, and B is there, and we'll call that J comma K. All right, and now I'm going to connect it. And now they said AOB is 150. So look, guys, AOB. So that is this part. So that is 150 degrees. But you kind of noticed, remember, theta is when we start from the positive x-axis and go counterclockwise. So we really care about what the heck this is. So it says the explement, which is what that green part is the positive difference from 360. So this theta they're asking me about is 360 minus 150. Let's see what that is. That gives me 210 degrees. So the actual theta they want us to find is 210 degrees. The radius is 1, because from 0, 0 to 1, comma 0, right? So we want to find the tangent of that angle. So the question's basically just asking me, what is the tangent of 210 degrees? So now that you figured that out, it's basically everything we were just doing before, right? So the reference angle, let's see, we're going to draw a reference triangle. The reference angle is 210 minus 180, which is 30. And then this angle over here is 60. Across from, let me get some of this out of the way. Across from 30 is a 1. Across from 60 is a root 3. They're not literal lengths, guys. They just help us find the ratio. I know I'm about to put a 2 here, which contradicts that the radius is being 1. Remember, those aren't literal lengths. Those just help me find the ratio. Okay, so now we're going to do tangent. So we're going to do, looking at this reference angle, opposite over adjacent, opposite over adjacent. So the tangent is 1 over square root 3. We rationalize that, so we multiply the top and bottom by root 3. And we get root 3 over 3. But I always got to check the sign, guys. So ASTC. Seems like we actually are in the tangent quadrant. So tangent is positive there. So the answer should just be positive root 3 over 3. Let's check it on the calculator, make sure it's right. Okay, looks good. Okay, question 12. So this was trying to warn you about in the slide, guys. They write student-produced response questions. This is a common thing on the SAT. They write student-produced response questions in a way that kind of force you to get the exact answer. So everyone in my comments, they always say things like, wait, can I just guessing check using the multiple choice? No, right? A lot of times, sometimes you can't. So don't get too reliant on that. Anyway, so let's go through this. So first things first, 2 pi over 3. I do not want to deal with radians, so let's make that degrees, 180 over pi. And I put that on my calculator, and I get 120 degrees. So we've got A with a set of coordinates of 8, 0, and then O with a set of coordinates of 0, 0. And then B is at where J is a negative constant and K is a positive constant. So it's in the second quadrant. So let's draw that. And I'm going to connect it. And you see AOB. It's not talking about this angle here. When I say angle AOB, we're referring to the minor angle, the smaller one. So this angle here is 120 degrees. And that is our theta. Now, the really important thing with this one is you see it's not 1, 0. So 0, we've got 0, and we've got 8. So the distance from 0 to 8 is 8. So the radius of this circle is 8. So we should write that down. All right, now it wants us to find k, the y-coordinate. So y is equal to r sine theta. And the y-coordinate is k. So I'm going to do k is equal to r, so that's 8. And then sine of 120 degrees. And now we're in business. Now we just need to figure out sine of 120 degrees, and we're good. So the reference angle, let me draw my reference triangle. The reference angle is 180 minus 120, which is 60. And 90 minus 60 is 30, so this guy is 30. Again, guys, these are not literal lengths. I'm just doing this to help me figure out the ratio, so just pretend they're not really real lengths. So across from 30 is 1. Across from 60 is root 3. The hypotenuse is 2. Again, that makes no sense. Just pretend. I'll put a little question mark here. 2? Like what? That should be an 8, right? It just, doing it this way just makes it so you don't have to find the actual lengths. Makes it a little easier, I think. All right. So we're going to do root sine of 120. So we're going to look at this reference angle. And we're going to do root 3 opposite over hypotenuse. Root 3 over 2. So we get k equals, and if we do ASTC, sine is positive in that quadrant, and plus they told us k was a positive constant anyway, so we expect to be positive. And so we do 8 times root 3 over 2. Well, 8 divided by 2 is 4, so k is equal to 4 root 3. And the question says it could be written in the form n root 3, where n is a constant. So let's hold that up next to it. N root 3. Okay, it is certainly looking like to me that n is equal to 4 if you hold it up next to it. And that is the answer. So you see, even though there's no multiple choices, they still found a way to force me to put it in the exact form. They very rarely have you round on the exam. Let's put 8 sine of 120 into the calculator and make sure we did it right. Okay, looks good. So we get 4 root 3, and the question said n root 3, so that means n is 4. Very good. Okay, everybody, thank you so much for watching until the very end of my video. I truly appreciate it. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.